Welcome scholars, Mr. Spears here bringing you another lesson from the world of science. Today's lesson is entitled Significant Digits. You might hear other teachers refer to these as significant figures. Either term is correct and means the same thing. When I teach students significant digits, I like to refer back to their understanding of measurement. In this example, I have two graduated cylinders. We'll call them A and B. And what I want to do is I want to look at these two graduated cylinders, find the volume of the liquids in each, and I want us to compare the measurements. Let's take a look at graduated cylinder A. What would be the volume of the liquid inside this graduated cylinder? Well, if I look here, my meniscus falls somewhere between 19.5 and 19.6. Okay? If I walk that over to the side, that puts me somewhere about halfway between 19.5 and 19.6. Of course, you know that you've been taught in class that you measure to the smallest mark possible and then estimate a digit beyond that. So then what does this measurement become? Well, we would write down 19.5 because it's at least that much, and then we're going to estimate a digit beyond that. Since it's about halfway, we're going to say 19.55, and then of course put our units. So the volume according to graduated cylinder A in this cylinder is 19.55 milliliters. Alright, let's do the same over here with the liquid in graduated cylinder B. If I look up here, my meniscus falls somewhere between this mark right here, which, if I look at the graduated cylinder, this would be 19, and then of course the mark of 20 that we see here with this big mark on our graduated cylinder. Alright, so again, the rule is to estimate one digit beyond your smallest mark. Our smallest mark here is 19. That we can be sure of. And so if I measure a digit beyond that, or estimate a digit beyond that, I'm about halfway between 19 and 20, so I'm going to say 19.5 milliliters is the volume in graduated cylinder B. Alright, so let's take a look at these two measurements, 19.55 milliliters and 19.5 milliliters. Now if I had to poll the class and I said which one of these measurements is most accurate, I would be pretty sure that the majority of the class would choose the measurement made using graduated cylinder A, 19.55 milliliters. Now, what I want to pose to the student watching this is, why would they choose that? Well, you can look at these two numbers. They're very close to one another, but the measurement of 19.55, you'll notice, has an extra digit tacked on the end there. And most students will say, well, 19.55 has more digits, therefore it's more accurate. Well guys, what I want to show you here is that the digits in a measurement or in a calculation, the amount of digits that are there, where they're positioned, things like that, those attribute to or contribute to the accuracy and the precision of these measurements and calculations, and therefore we say that they're significant. When I teach students how to figure out which numbers are significant in a particular number or measurement, I have them think of the number as being surrounded by the United States. So here we have 0.002301. And if you recall from geography class, the United States is flanked by two oceans. We have the Pacific Ocean over here on the left and the Atlantic Ocean over here on the right. So take a look here at this number, 0.002301. When you're trying to figure out what digits in a number are significant, look for a decimal point. In this number, the decimal is present. Okay? The P in Pacific stands for decimal present. Whenever there's a decimal present in a number, when you're trying to figure out what the significant digits are, start on what would be the Pacific side of that number. That would be the left side. And what you're going to do is you're going to move across that number from the left, and you're going to be looking for something. And what are you going to be looking for? Well, what you're going to be looking for is the first non-zero digit. The first non-zero digit moving to the right is this 2. Now, the first non-zero digit, and actually any non-zero digit in a number, is considered significant. But this first one is most certainly significant. And then the rule is any digit that comes after that is also significant as well. So as I keep going to the right across the number, or across the continent if you consider United States, the 2, the 3, the 0, and the 1, these are all significant. Now you might say, well, what about these other zeros that came before? Well, if you recall from our scientific notation lesson, these zeros right here, they don't contribute to the accuracy or the precision of the measurement or the calculation. They simply are there to tell us how big or how small the number is. We call them placeholders. Let's move on to another example. Here I have another number, 134,000, and I want to figure out which digits in this number are significant. Well, just like with the previous example, what we were looking for is the presence of a decimal. You'll notice that in this number, the decimal is absent. Now, Atlantic, the word Atlantic begins with an A. I want you to be thinking, when the decimal is absent, I want you to be thinking about the Atlantic Ocean. The Atlantic Ocean is on the right side of the United States. Therefore, when you start scanning the number for significant digits, what I want you to do is I want you to start on the Atlantic side and move across the number, going to the left. Okay? So as I move across that number, what am I looking for? Well, I'm looking for the same thing in the previous example. I'm trying to find the first non-zero digit. So as I move to the left, my first non-zero digit is this 4. This 4 is significant, and any other digit that comes after it moving to the left. So that would be the 4, the 3, and the 1. And once again, we see here that these digits, these 3 zeros that are left at the end, they are not significant. They are placeholders. They are just simply there to give us some idea of how big this number really is. Alright, so now that we know how to tell which digits in a measurement or a calculation or a number are significant, let's go through at least a few examples and see this in action a little bit more closely. It says, mark which digits are significant in the following measurements. Alright, so let's start with number 1, 10 milliliters. 10 milliliters. Okay, one thing I want you to notice is that there is no decimal here with this 10 milliliters. So the decimal is absent. Absent, think A, think Atlantic. I'm going to start on the Atlantic side of this number, and I'm going to move across, going towards the left. I'm going to move across until I find my first non-zero digit. My first non-zero digit is the 1. This 1 and anything else that comes after it is significant. Well, there's no more digits after that 1, so in this measurement, only the 1 is significant. Example number 2. We've got 0.120 centimeters. Alright, so which of these digits are significant? We notice that there is a decimal present in this measurement, and so decimal present, P, Pacific. The Pacific is on the left side of the United States, so I start on the left side of the number, and I'm going to go across it towards the right, and again, I'm scanning for the first non-zero digit. So the first non-zero digit that I come to is this 1. That digit and any other digit that comes after is significant. So that means the 1, the 2, and then the 0 at the end. Alright, let's move down here to example number 3. Example number 3, we got 1,209 cubic centimeters. Okay, once again, check and see, is a decimal there? We notice that a decimal is absent from this number, so we're going to start on the Atlantic side, and we're going to move towards the left. Again, we're looking for the first non-zero digit. That would be this 9 right off the bat. This 9 and any other digit that comes after it is significant. Okay, I'm going to give you 4 and 5 to work on your own. When I tell you to press pause, I want you to do so, and then try to see if you can identify which digits in these measurements are significant. Then I want you to press play, and then I will write up what the answers for these two are, and you can see if you got your answers correct. Go ahead and press pause now. Now that you know which digits are significant and which ones are not, the next skill I want to teach you is how to round to a specified number of significant digits. Take the number 548.601203 as an example. Let's say I wanted to round that to 3 significant digits. How would I do that? Well, the first thing I want to do is I want to use my Atlantic and Pacific rules to determine which digits in that number are significant. I notice that there is a decimal in the number. Therefore, I'm going to use my Pacific rules to determine which digits are significant. So moving across left to right, I want to find the first non-zero digit. The first non-zero digit is the 5. This 5 and any other digit that comes after it are significant. So I know from using the Pacific rules that the 5, the 4, the 8, 6, 0, 1, 2, 0, 3, all of these digits are significant. Next, what I want to do is, since I'm asked to round to 3 significant digits, I want to determine or figure out what are the first 3 significant digits in this number. Well, reading this number like a book, the first 3 significant digits are the 5, the 4, and the 8. Now when I'm rounding, I always want to look at one digit beyond what I'm trying to round to. In this case, it would be the 4th significant digit. If that number is a 5 or greater, then it is going to round the last digit you're trying to round to. In this case, the 4th digit is going to round the 3rd digit, the 8. So the 6 is 5 or greater, so it's going to round the 3rd significant digit, that 8, to a 9. So we round that digit and that digit only up 1. Okay? So the 4 rounds the 8 to a 9. So what I end up with is my number changes slightly, and I get 549.601203. All right, lastly, to finish up, what I want to do is I want to drop all but the number of significant digits that I want to keep. Since I'm rounding to 3, I'm going to drop all but the first 3 significant digits. So that's going to be all of these after the decimal point. So my number becomes, rounded to 3 significant digits, becomes 549. If you use the Atlantic rules on that number, you'll see that there's only 3 significant digits. And one thing I want to say before I move away from this screen is, if I drop any number that comes before the decimal point, I want to replace that with a 0 when I write my new rounded number. These zeros are going to serve as placeholders. Okay, we're going to work through a few examples so you can get the hang of this, and then again I'm going to give you an opportunity to do a few on your own. Our first example, what we want to do here is round this measurement of pascals. We want to round this to 3 significant digits. So first thing we're going to do is we're going to identify which digits are significant. No decimal is present. It is absent, so I'm going to start on the Atlantic side, move towards the left, and I'm searching for the first non-zero digit. That would be the 4. That and every other digit that comes after it is significant. Next, what I want to do is, since I'm rounding to 3 significant digits, I want to take a look at my first 3 significant digits. And then I'm always going to take a look at the one right after what I'm trying to round to. That would be the 4th significant digit. Remember, if that digit is 5 or greater, it's going to round this 3rd significant digit. If it's less than 5, then we don't round the third significant digit. This 8 is indeed greater than 5, and so that 5 is going to become a 6. And then I'm going to drop any other digit after that third. Now, since I dropped digits before the decimal place, I want to replace those with zeros when I write my answer. So I dropped 5 digits before the decimal, so I'm going to write 206 and then tack on 5 zeros as placeholders. So this measurement rounded to 3 significant digits is 20,600,000 pascals. Number 2, we have 0.004304 millimoles. That measurement is asked to be rounded to 2 significant digits. Using the Atlantic and Pacific rules, I notice that there is a decimal, so I'm going to start on the Pacific side, and I'm going to move to the right. First non-zero digit is 4. That and every other digit that comes after it is significant. Next, I want to take a look at the first 2 significant digits, since that's what I'm rounding to. And then I want to look at one more, which would be the third significant digit. I want to see if that's going to round the second. 0 is less than 5, so the third significant digit will not round that 3, and so that 3 is going to stay put. And so then what I'm going to do is now I'm going to drop all but the first 2 significant digits. So this 0 and 4 on the end, they're gone. Since I didn't drop any number that comes before the decimal, only after, I don't need to replace what I took away with zeros. So my answer becomes 0.0043 millimoles. Okay, what about when I have a number that is written in scientific notation? Here we got 5.009 times 10 to the 12 atoms, and we're asked to round that to 3 significant digits. Well, to round a number that's written in scientific notation, the first thing you need to do is you kind of need to briefly ignore the times 10 part. Now we're not discarding that, we're just ignoring it for right now. And so now I'm going to work with just the number that's written in front of the times 10. So let's take a look at 5.09. If I'm trying to determine which numbers or digits are significant there, again I'm going to notice that there is a decimal. Decimal is present. I'm going to start on the Pacific side. As I move towards the right, the first non-zero digit is the 5, and then that and every other digit that comes after it is significant. Since I'm rounding to 3 significant digits, I look at the first 3 significant digits, and then I look at one more to try to determine if it's going to round the third. Alright, 9 is 5 or greater, so indeed it will round my third significant digit, that 0, to a 1. To a 1. And now I'm going to drop all but the first 3 significant digits. So that 9 is going to go in the trash. Now, when you're writing your answer, you're going to write down 5.01 and now bring back the times 10 to the 12 and tack that onto the end. So 5.01 times 10 to the 12 atoms. Again, if you were to use your Atlantic and Pacific rules on this number, you would see that now this has 3 significant digits, which is what we want. Okay, I'm going to do one more. I'm going to do this number 5, 0.11110 ohms, and we're to round that measurement to 4 significant digits. I see right off the bat that there is a decimal in this number. Decimal is present. I start on the Pacific side. I move to the right and find the first non-zero digit. That and every other digit that follows is significant. All right, since I'm rounding to 4 significant digits, I'm going to locate the first 4 significant digits in this number, and then I'm going to take a look at one beyond that. That would be the 5th significant digit. I'm looking to see if it's going to round my 4th significant digit. That 0 is less than 5, so it will not do anything to this 4th significant digit. That 1 will stay a 1, and so I'm going to drop all but the 4 significant digits. In other words, I'm going to drop the rest of my digits on the end, and then my number rounded to 4 significant digits is going to become 0.1111 ohms. 4 and 6 are yours to practice. When I say press pause, you will do so, and then when you are finished, hit play, and I'll write the answers to 4 and 6. Go ahead and hit pause now. Lastly, I want to review some special situations that you might encounter. What am I talking about? I'm talking about a situation where you're asked to round to a certain number of significant digits and you actually have less than the number that you're trying to round to. Now, to get around those type of roadblocks, this is where you're going to use the skill of scientific notation that we've been learning in class so far this year. Let's, for example, take a look at this first one, 30,000. Let's say that you did a calculation. This is what you got. How do you round that to 3 significant digits? Well, first thing is figure out how many significant digits that you actually have. Decimal is absent, so I'm going to start on the Atlantic side. First non-zero digit is the 3, and then of course there's no digits afterwards, so 3 is the only significant digit in that number. Now with only one significant digit, how in the world am I going to round it to 3? Well, you can round it to 3 significant digits if you first convert it to scientific notation. So 30,000 written in scientific notation becomes 3 times 10 to the 4th power. Alright, notice I still have just simply one significant digit. But if I add a decimal point and tack on 2 more zeros, now when I use Pacific rules and scan that number, you'll notice that I have 3 significant digits in my number. So 30,000 rounded to 3 significant digits becomes 3.00 times 10 to the 4th. Example number 2, 0.0092. Decimal is present. Start on the Pacific side. First non-zero digit is the 9. That and anything that follows is significant. So in this number, I have just 2 significant digits, but I'm asked to round to 3. Pretty impossible the way I have the number written right now. But what I'm going to do is I'm going to take this 0.0092 and I'm going to convert it to scientific notation, so it becomes 9.2 times 10 to the minus 3rd. Okay, the number still has just 2 significant digits. So what I'm going to do is I'm going to tack on an extra 0 after the 2. And now when I use my Pacific rules, I notice that I have 3 significant digits. So my answer is 9.20 times 10 to the minus 3rd. Last but not least, 709,700. First thing I'm going to do is determine the significant digits. The decimal is absent, so I start on the Atlantic side. First non-zero digit is a 7. That and everything else that follows is significant. Now you'll notice that in this problem we have 4 significant digits, and so you're saying, well, what's the problem? Well, the problem comes when you look at that 4th digit. That 7 is going to round the 9. Well, what is the 9 going to be rounded to? It's going to be rounded to a 10. And so what we end up doing after we drop all our numbers and replace them with zeros, we end up getting a number of 710,000. we get a number of 710,000. Now, if you scan that real fast using the Atlantic rules, we see that this number only has 2 significant digits. So we have a little bit of an issue. But this can be resolved by converting it to scientific notation and adding some zeros. So 710,000 becomes 7.1 times 10 to the 5th power. 2 significant digits, I'm going to simply add another 0. And now using Pacific rules, I have 3 significant digits. So my answer becomes 7.10 times 10 to the 5th power.